let's get into, before we get into the genetics evidence, the earthquake metaphor. Okay, suppose if you hear of an earthquake, and as soon as you hear of it, and you are a sensitive individual, someone who keeps oneself aware of what's happening around the world, someone who is a curious, someone who studies things all the time, what are some of the things that you would want to know about that earthquake? Okay, I have asked this question to many individuals when I give lecture and when I share this, or when I discuss this genetics evidence. I consistently get the correct answers. For example, people definitely want to know where the earthquake took place. The second, they want to know when it took place. Oh, when did it happen? Is it like a week old and still I didn't hear about it? Oh no, it was the last night. Usually the news such as earthquakes spread very fast in terms of the urgency, the sense of urgency of it, right? Just like a tsunami. So the timing of it and the intensity, the Richter magnitude scale. And just because I use the word tsunami, I would say that also applies to tsunami, but let's stick with the metaphor of earthquake. So where it occurred, when did it occur, and the intensity of that earthquake are the typical questions that you would hear. Just take this as a metaphor, and we are now going to apply this to the genetics data that we just looked at from Carmen's paper from 2015. Okay, so again, our scientific framework, we are looking at this evidence here, and let's see, that's our evidence. Now I'm magnifying that graph so you can see it very clearly. Uh, on the y-axis is that NE ratio. Okay, it's the diversity in genetic diversity among the female population, you can say, or the female side of the gene flow, like mitochondrial DNA, that's X chromosome. Okay, X chromosomal DNA, you can call it. The male diversity is based on the Y chromosomal DNA. And what you are saying is that ratio was highest 16:1, and that occurred here. And if you do the scale, the x-axis scale of the time, that happened around that 7,000, 7,500 years ago. Okay, that's so sharp, that's so precise for our purposes. Okay, as it happens. So think of this as one piece of information. Think of this, that 16:1 as equivalent to that Richter scale of an earthquake, equivalent to that. And I'm drawing some lines and I'll explain you what they mean. The first one is the intensity of this imbalance, 16:1. Remember that. And this is not a linear imbalance. Okay, you can think of, don't think of it in terms of just 1:1. No, this can be, it can be thought in the sense of a geometric progression, but I'll leave it at that. Let's consider it 16:1. That's a huge imbalance. Now you have to stay with me. Look at this South Asia line. That's this forest green color. They started with this particular research group of researchers. They started with 12,000 years ago as like a control point, a basis point. Let's imagine that all the diversity, whatever the diversity that was almost equal between all the populations of the world. Okay, it's not equal. They're just taking that as a reference point. So that's why they all are here together. Now, as the time passes, the first diversion that you see, of course, you may see this uh, for Africa, but again, it's important. Either you are someone who has done a lot of modeling, this because what you're seeing, these lines, smooth lines, are essentially the modeling based on a discrete data. Okay, lots of data points, hundreds of data points, but they are still discrete data points. So if you are into modeling, you wouldn't have these confusing problems. But if you are not, then you have to take on a shraddha, on the faith, what I am telling you is the case. But you can always go back and learn more about it. So otherwise, there is too much noise and you will miss the main important point. So what you'll see, the first signal, a distinct signal that you see of a deviation, is for this forest green line, as I draw this, I mean, as they have drawn it. Okay, so it's the first green signal that it deviates from that original and it reaches the bottom. Okay, it's the first one to reach the lowest number, which is the deviation. Okay, that's 16:1 that we're talking. Okay, I'll just continue with that. And then remember, it stayed at the bottom, which is to say the deviation between male versus female genetic diversity stayed that way, might have actually gone down, but stayed that way for the longest, which is to say it was the last one to recover and come back to make it a balance as close as it gets. Okay, when did it started coming back? Actually around like a 4,000 years ago, so like by 2000 BC. So from somewhere here around, like let's say 8,000 or 8,500, somewhere the model shows like that. So that is what, 6,000 years, 6,000 BC or so. It experienced that deviation, stayed that way. It experienced the highest of all the different regions, stayed that way, and it was the last one to recover. South Asia, do you know what that place is? India. Now let's look at, so therefore I have drawn this other horizontal line to show you what are the regions. So for example, below this horizontal line, the two other regions that fall off, which is what? One is this blue color line, which is Southeast Asia. Keep that in mind. There is a very good likelihood that people from Southeast Asia also participated into the Mahabharata war. They were also the one to experience this deviation in the female to male diversity. All right. Now they recovered much faster in compared to India. So they started recovering say 5,500 years ago, which is what, 3,500 BCE. The third one is the Near East. Okay, they were also the one to experience the deviation among the first few. These three, they also saw the bottom, actually a significant deviation, female to male ratio, but they recovered also. They recovered faster. Rather, they started recovering right away, and you can see that by 6,500, which is what, 5,500 BC, and the recovery was very, very swift. Let's look at the regions that did not participate into the Mahabharata war based on Mahabharata narrations. For example, Andes, okay, that is South America. Look at this color here. In fact, there was absolutely no deviation until 3,000 years ago, which is what, 1000 BC. And whatever could be the causes, we don't have to go into that, because remember, the timing that we are investigating in the context of Mahabharata is this second vertical line here at that 7,500, 5561 BCE. Okay, so no effect of this at all on the Andes population in terms of female to male diversity variation. If you look at Siberia, look what you find. Almost practically no deviation, definitely not here. And then you see some deviation, and it keeps on going down all the way until 1,000 years ago. And then suddenly it picks up back. I mean, we don't know, maybe it's a limited data set that sometimes can do that. But again, it's not consistent with what you saw for India, for Near East, which is, we can call Middle East, like Iran, Iraq, Turkey, or Southeast Asia. Okay, let's look at something else. Oceania is actually not shown, so they must have very few data points. Now, two other areas are distinct and worth noting down. One is the Europe. See, you don't see any difference, or not a noticeable difference 7,500 years ago in the Europe, okay? But something interesting, by the time of, I would say, 6,000 years ago, which is 4,000 BC, now keep that in mind, by 4,000 BC, suddenly, as if something happened in Europe to their female to male diversity. Keep that in mind, okay? And then, of course, after some time, it recovered. Ditto for Central Asia. Initially, no effect during this 6th millennium BC. This is this line here, whatever that color is, here, parrot green. I don't know what that color is. I'm colorblind. So this here, this until this time, 6,000 years ago, 4,000 BC, no difference. But now suddenly they experience the same thing that India, the Near East and Southeast Asia has experienced 7,500 years ago. So they see that dip in the deviation in the female to male genetic variation, and they also quickly recover and so on. Very, very interesting. Now let's understand what is it the data is telling us. So 16:1 is the, think of equivalent to the Richter scale, the intensity of the impact. Now this is a genetic impact, a gender biased impact. Many men are gone, 4 million worth of men are gone, and so the progeny that is created after this event is essentially what? Practically the same number of female or same genetic diversity among the female groups, but the genetic diversity of the men has gone significantly down. So few men are now the father, okay, for the progeny. Now, epicenter of this, based on this genetic data, is India. Why? It is the first one to start seeing the deviation, intense deviation. First one to see the bottom. It was the one that stayed there the longest with that deviation, and it was therefore the last one to recover. So epicenter is India. When did this happen? It happened around 7,500 years ago, that is 6th millennium BC, and I'm taking the middle of 6th millennium BC, just so happens 5561 BC, the timing of Mahabharat war. What is important to remember is that while this fixed point of 7,500 years ago, or 5561 BCE, the middle of 6th millennium, is not very clear or easy to see from this graph, it is absolutely clear and easy and crisp to see from the previous graph that I showed you. Okay, all right. The next one, again, India was the first to experience the change, that forest green line, okay, and it reached the highest magnitude, it went down, okay, and not just that, it stayed there for the longest time, and therefore it was the last one to recover. Again, you can relate this to the metaphor of earthquake. The place that is the epicenter usually, not always though, but usually will be hit the hardest and might take the longest time in the absence of any external help to recover. Okay, so think of that as an equivalence. All right, that's the guys, that's the evidence. Okay, and it's a so if you are into modeling, if you understand genetics, if you understand what this male population can do, then I don't need to explain it any further. But for those who may feel overwhelmed, they should study this, take some time and study this with respect to the what was happening in the Mahabharata, and um, you will find that this is very revolutionary, phenomenal, empirical, objectively testable scientific evidence. Okay, quickly, I want to give you a corroboration of a corroboration. So what this evidence did is beautifully, impressively corroborates 5561 BCE as the year of the Mahabharat war. That Mahabharat war, which lost 4 million or close to 4 million men who came from the India as we see it today, but the external or greater India, which would include modern day Pakistan, Bangladesh, Nepal, even parts of Tibet, going all the way to the western parts of China, Turkmenistan, east of Caspian Sea, possibly parts of Iran, Iraq, Turkey, and so on. Okay,